In this video, I'm just going to talk through some of the configuration options that you have for Experiment Catalog. These are all documented in the README inside the catalog folder. But in case there's any questions on it, I can talk a little bit more about this. Log level is pretty straightforward. Trace debug information, warning, error, critical, none. You can really set it to any of those levels. It defaults to information. Not even going to go over this. That doesn't really matter much. Include credential types. This determines if you're going to use default Azure credential for connecting to the storage account. This determines how it's getting those credentials to connect. So AZCLI, ENV, that's going to be your default. But if you have it as a deployed solution, you might use managed identity, whatever. In a perfect world, just set this to the value you want to use. So you can see all the different options here: AZCLI, ENV, managed identity, a token, Visual Studio Code, or browser. Usually this is either going to be AZCLI, ENV, or managed identity, and just set it to the specific value. If you put multiple values, it takes a little bit longer to resolve. So if you set it to the specific value you're intending to use, that's the best choice. Port, this is the port that the API will run on. So you can set that to whatever makes sense. Default 6010. Open telemetry connection string. If you don't put anything in there, then that telemetry information doesn't get logged anywhere, like your logs or traces or anything. Exceptions, those sort of things. If you do want to use this, you put in an application insights connection string here, and that will send all the information to App Insights or Azure Monitor. Azure storage account name or connection string. You have to have one of these two things. An account name, if you're going to use default Azure credentials. So basically, if you're going to use the include credential types, that will determine how the storage account is resolved when you give it the storage account name. So it'll either use AZCLI, environment variable, or managed identity, or the most likely choices you would pick. Alternatively, you can put in a connection string, but then that's a secret. So just be careful with doing that. Concurrency. This isn't used a whole lot, but for things like loading experiments, for example, this determines like the number of threads that can be run for loading experiments at the same time. Because experiments can be big, I mean they can be 30 or 40 or 50 meg, then you want to have some control over how much is happening at the same time. 4 is a decent number. If you want to give it more resources and more concurrency, bump it up to 8 or 16. If you have lots of people using the catalog, that may improve your performance. Alternatively, you can also run multiple replicas of the catalog, and that can be another way. This concurrency setting would be per replica. Required block size for optimize. Okay, so the solution uses blob storage as append blobs, and so the purpose of that is because you can pump a whole lot of data, thousands of records per second, into there at the same time and not have any problems doing so. But what that means is that every one of those records coming into the system is a block, and then you end up with a whole bunch of blocks, which is really inefficient for reading. So very, very efficient for writing, but very inefficient for reading. And so when we are done with an experiment set being pumped into the catalog, what you really want to do is optimize for reading, which is to take all of those very small blocks and pack those into very big blocks. The setting down here, Azure Storage Optimize every X minutes, determines if this node goes out and looks for blobs that need to be compacted. And you'll notice that it defaults to 0. The reason for that is because you could run lots of different catalog instances. You could run it locally. You could run 3 or 4 replicas out on a server, whatever. But you only want one instance really doing optimization so that they're not competing with each other to do optimization. So by defaulting them all to 0, that ensures no system is doing optimization. And then whichever system you want to do optimization, bump that one up to every 10 minutes or 15 minutes or something like that. And then what it will do is all the blobs, it'll look at these two settings then, right? So for every blob that's out there for an experiment, if the required block size is smaller than this value, then it'll optimize the file, and it'll only do that if the file has been idle for this number of minutes. So you don't want to optimize if data is still being pumped into the file. You want to wait until the experiment's finished. So this, this just gives you can put the number to whatever. It defaults to 10 minutes. But if it hasn't received new data in 10 minutes, then we assume that the experiment is done pumping data into the catalog, and then consequently it might be eligible for optimization. And then we look at the blocks, and if the block size is too small, then we optimize it. Hopefully that makes sense. So really these 3 settings work in tandem, and these are reasonable default values for these 2, so you probably don't really need to change those. What you do need to do is set one production instance to do the optimization run, and only one instance to do the optimization. Okay, this minutes to be recent, I'll get back to. That actually relates to values. Well, it actually relates to this value, so we can talk about this now. So calculate p-values every x minutes. What this does is calculates the statistics, and this is by default disabled. And again, you don't want to have more than one instance of this turned on. But on one instance that's pointing to the to the storage account for that catalog, you could turn this on and set it to 10 minutes or 15 minutes or something. And what's going to happen then is every 10 or 15 minutes, it's going to attempt to calculate the statistics values for recent experiments, and this determines what recent means, in this case 8 hours, for experiments that are idle. So if it's a recent experiment and it's idle, and we don't already have statistics calculated for it, then this will calculate the statistics. You don't have to turn this on at all. You could leave this off. As you might recall in one of the other videos when we showed the catalog, there is a manual option to calculate statistics. So you don't have to have it turned on to do automatic statistics calculations. You could just have users manually running them. Anyway, if you want them automatic, this is the setting to do that. And then calculate p-values using x samples. This is the number of samples to use when calculating the statistics, and by default that's 10,000. Again, a reasonable number, but I mean you can bump it up or whatever if you need to. The minimum iterations to calculate p-values. So generally you run an experiment with a certain number of iterations. If the number of iterations is too low, then you're not the statistical significance of the p-value is not very useful. 5 is really kind of the minimum you would want to have, 5 iterations before you could realistically calculate p-values. So I wouldn't probably set that lower, but you could optionally set it higher if you wanted to ensure that. And all this really does is if it finds a experiment set that does not have at least this number of iterations, then it will skip it when it goes to calculate the statistics. All right, confidence level. This is the level it tries to use for statistical calculations, and generally we're trying to set that to 0.95. I mean, I think that's a reasonable number. I probably wouldn't go lower than that. precision for calc values, number of decimal places to use. Again, 4 is probably fine, but if you needed more precision, you could increase that number. Okay, path template. This is related to this anonymous downloads capability. So if you turn on anonymous downloads, then there is an endpoint that you can hit to download it's basically this endpoint here, /API download. This endpoint by default is off, so you can't download files. If you turn this to true, then if you hit this endpoint, and the file that the path that you give it to download is either on the primary storage account, as defined by one of these two settings, or it's in the storage account defined for support docs. This is more specific, so this takes precedent over the other one. But if it's one of those two storage accounts, and that's what you're choosing to download from, and you have this option turned to true, then it will download and feed the file to you. The purpose of this being that in the UI, when you click on the INF or the eval for the download, that it will stream the file from that location. So if we just look at this, you can see here our URL is the path where we have it deployed, /API/download, and then the URL is the URL of the evaluation file. So that lets you download and get the file off of that blob storage account. So you need to have this turned to true, and you need to either have this define the account name for the support docs, or the account name for the support, or the connection string for the support docs, or those supporting documents have to be stored on this storage account. And if all those things are true, then you can use this for downloading. Alternatively, you can deploy your own viewer as opposed to just downloading the JSON document. You could get a more advanced application to view those inference and evaluation files, and maybe have other statistics and everything that you calculate in those. In which case, you can use the path template to point to that other tool. All this does is replace this value with the URL that's stored in the data record. So when the evaluation system sends an inference file or an eval file, it's sending the path to that inference file or that eval file, but not the tool to view it. That's what the path template is giving you, is the tool to view it. And then it replaces this with the actual file that's in there. So if you're using your own more advanced tooling for viewing the files, great. If you're using the anonymous download tool here, just turning this on, great. You can use that with the path template. If you don't have this at all, it will use the exact URL that was passed in to the input, in for the record that was pushed to the catalog. The Azure Storage cache folder. So I mentioned that these experiment files can be large. They can be 30, 40, 50 meg or whatever. So as an effort to improve performance, you can optionally set a cache folder. And if you do, then those files, those experiment files, when they get downloaded, will be stored to that cache folder. They're stored using the eTag. So as soon as the file changes on the server, that invalidates the cache. There's no special thing you need to do. But this can improve performance by locally storing the files, so you don't have to go to the server every time to get them. This max age in hours just determines how long to keep the cache file. There's a job that will delete the stuff from the cache folder if it's older than this size. Really, the purpose of this is just so you don't grow the cache really huge. What tends to happen is you're using a lot of experiments from a particular project, like a sprint, and then you move on to another sprint, and you're hardly, maybe you go back and reference, a file or two occasionally in the old sprint, but usually you're looking at the current sprint, and so you really don't want this to just kind of grow out of control, so the old stuff will age out, and that's what this setting does. And then the cache cleanup determines how often the job runs to delete those old files. So by default, every 2 hours. Probably don't ever need to change that. Test projects. So the only thing that this is used for is for this. I mentioned all of this stuff around calculating p-values, which is the statistical values for it. We don't calculate statistical values for test projects. So you can create a common delimited list of the names of your projects, right? So Sprint01, Sprint02, whatever, to exclude from p-value, automatic p-value calculations. The purpose of this tends to be because usually you'll create something like a smoke test project or whatever, where you're just dumping a whole bunch of test data that's not actually related to real experiments. And if you do that, you don't typically want to calculate p-values for all that stuff, because it's just, you'd be burning a bunch of calculations on a bunch of test data that you don't care about. So this provides you a way to exclude that. And that is the last of our settings. Thank you.